Look in more detail at each of these three reasons to use a loop. Well, the first question is about intercepted wake-ups, and the question is really, should you signal a condition variable before or after you unlock its associated mutex? If you signal first, then you wake up a thread, and that thread will try to get the lock, and with this is behind the scenes, and it will just find that it's still locked, so it will wait for the lock, for the mutex to be free. And this is unnecessary overhead in terms of instructions and cache misses. On the other hand, if you unlock first, then another thread, completely unrelated to the one that is waiting, may take the lock and do something with the data, and that's not wrong, but the effect may be that the predicate for the waiting thread is no longer true, and this is called an intercepted wake up. And due to intercepted wake ups, you need to check the condition in a loop. Again, loose predicates may not be the most useful thing, but it is also a reason for having a loop. And it is simply that it doesn't promise exactly that there is something to do, but the thread must check it out by itself. And if there was not something, then it should sleep, and not sleep, but wait until there is something new. Spurious wake-ups. Okay, so now we need to explain something about Unix system calls. And when you hit Ctrl+C to terminate the program in a terminal, that is the same for most operating systems, then you send in the terminal a so-called signal. Well, this signal has nothing to do with the terminal, but it originates when you press Ctrl and C in the terminal. Okay, and this word signal, it has nothing to do with signal on a condition variable, although both, of course, mean that sending some piece of information. In the more general sense. Okay, and when a Unix thread receives a signal and it happens to be waiting in the operating system kernel for a system call to be complete, such as when it's reading from a file or anything, perhaps waiting for a condition variable, then that system call is terminated and returns with an error code called error interrupted. Okay, usually a signal is sent to a particular thread, but some signals can be sent to all threads of a process. A process meaning the running program that contains all the threads. So on some Unix systems, a waiting thread on a condition variable can be interrupted, and then it will wake up with such a spurious wake up. But in particular on Linux, this is not the case. Linux uses something called a Mutex, which stands for fast mutex. And the implementation of that, and the definition of it, is so that there will be no spurious wake up.